Okay, welcome to question 6, 2015, paper 1. Obviously this is a complex number question, as soon as they tell you the name. There's a part A worth 15 marks, a part B worth 5 marks, and a part B, part 2 worth 5 marks. That's your 25 marks. Now, I personally love complex numbers. They're starting off here with an Argon diagram, and they have the complex number Z1 plotted on it. I can actually go back to this is the question without any work done. So they're saying the complex number Z1, which is written as the real part and imaginary part, and A plus BI, where I squared equals minus 1, but that probably not be important, but it's just, that's a guiding principle of complex number. Numbers when it comes to the statement that I is called the square root of -1. If you square both sides, you're going to end up with I squared equals square and square root cancel, you're left to -1. And they're showing them, now there's a specific name, it's called an Argon diagram, very, very, very similar to an XY diagram, except the Y-axis is called the imaginary axis, and the real axis is in place of the X-axis. So first thing there says, part 1, write down the values of A and B. Okay, so the complex number there we're talking about is 3 plus 2i. So the real part goes first, it's the real part, and that's the imaginary part. So that's in the form A plus BI. So once you see that, you can go, well, the A part must be 3. Okay, so 3. And the B part must be 2. Okay, job done. Move on then. The image of Z1 under reflection in the real axis is a second complex number called C plus DI. Write down the values of C and D. So now reflection in the real axis, that's the real axis here. So your point goes down, takes the real axis, and on the same distance again. Okay, now this would actually be the conjugate as well. That's a different concept we need later on. But that's going to be the complex number 3 minus 1i. So that's in the form now of C plus DI. So the C is the real part. So again, that's 3 there. The imaginary part now is the full number, the -1 is the D part, the magnitude of the imaginary number. Okay, that's part A. So that's the answers just built in there, and the diagram showing the reflection. Now part B, part 1 here, okay, I have the two complex numbers Z1 and Z2 just represented here. You'd have had that from the original diagram. And what they're saying is the angle theta, now if you want to call that A, because if theta just puts you off, that's fine. Yeah. It's formed by joining Z1 to the 0 plus 0i, which is the origin, okay, to Z2. So I'm joining Z1 to the origin, to Z2. So theta is that angle, that full angle there. That's what you're trying to find. Okay, so find cos theta, correct to one decimal place. In fact, you're not actually trying to find the angle itself, you're just trying to find what cos theta is. Okay. Now, if you think about it here, now you could call that one big triangle. Okay. That's going to be a non-right angle triangle. Okay, those two lengths will be the same. And you could find them by using the modulus. And you could use, actually what could you use? Sine rule would work. If you found the length of all three sides, you could use the cosine rule, but that's going to be an awful lot of work. The smartest thing I would say to do is to split the triangle in two. Okay, if you find this angle here and double it, you get the total angle. Okay, so we'll go to the answer I've done out. And so okay, so if I look at the half angle here from the diagram, I'm going to try find the angle by using tan. So it's a right angle triangle. Tan is found by comparing the opposite side, which is this side, and the adjacent side, which is this side. The hypotenuse is the longest side. Okay, so it's the exact same triangle at the bottom. It's a mirror image of that top triangle. So if you see the units, that's 1 unit. Okay, you see it goes across 1. So it's 1 unit, and the bottom one is 1, 2, 3. Now I've stretched this image, so the 1 and the scale is different. That's not a problem in the diagram. It's allowed if they're different axes, as long as the scale is consistent across the same axis. So I'm looking for tan of an angle equals a third. Okay, what's the angle? Well, the angle is equal to inverse tan of a third, which put to the calculator I got 18.43. Now theta is 2 times the angle. Okay, So that's going to be equal to 2 times 18.43, whatever, which is the same thing as 36.86. Now they want cos of that angle, so put the 36.86 in the calculator, and I end up getting 0.8. Okay, there's a little bit of extra step at the end there, and I've corrected that to one decimal place just in the answer. I probably should have said units. Okay, I'm not sure there exactly. It's not the green, it's a length, but we're not given the units. So just to cover my proverbial, I give it just the word units, which I should have done initially. Now that's B part 1, so this is B part 2 left. A lot of work, in essence, a lot of thinking and work for 5B. And I don't like trigonometry, but this is classic use of it. Now the last one there is, okay, show that these bars mean distance, be that in coordinate geometry. In complex numbers we often call it the modulus, but basically it means the distance of that complex number from the origin. So show that the distance of z1 from the origin times the distance of z2 from the origin times cos theta, which is 0.8, equals a times c plus b times d. Now you remember a and c, you had them in part 1, part A, and b times d. So they tell you that a, b, c, and d are the values from part A. Okay, now the formula for modulus is here. It's a variant of the Pythagoras theorem. If I write out Pythagoras theorem here, it's the hypotenuse squared equals the sum of the squares of the other two sides. Okay, if you bring the square across, it becomes square root. I'll just get rid of that. Bring it across the equal, it turns into its opposite, which is the square root of everything on the far side. Let's go ahead with the answers. Okay, so I've done it here. I've written out all my complex numbers, Z1, Z2, cos theta is 0.8, and I've written out my 4 numbers. It's all right in front of me now. I'm actually doing this in one massive Uber-like calculation, but it's the distance of 3 plus 1 from the origin, 3 plus I from the origin, 3 minus I from the origin, the 0.8, 3, so A times C is 3 times 3 plus 1 times negative 1. So is left-hand side equal right-hand side? Let's see. Put the complex number into the modulus formula. So the 3 here is the A, plus the B for the modulus formula is the number in front of the I, which in this case is plus 1. So that's where I get my A and my B. And that's the same A and B here. A and B times 0.8. So this, you could put out the calculator as one big Uber calculation again, but I've gone down to where that's the 3 squared is 9, plus 1 squared is 1. 9 plus 1 is 10. So square root of 10 times square root of 10 times 0.8. Is that equal to, now I've done the left hand side here, so the right hand side, and that comes out to be 8. Now square root of 10 by square root of 10, without even a calculator, that's the same thing as square root of 10 squared. So the square cancels the square root, and that's where I get this 10 here in the bottom. I still have to multiply that by 0.8, but 10 by 0.8 is the same thing as 8. So therefore 8 is equal to 8, and the above statement was true. Now you could do this as separate sections, but remember you don't have an outrageous amount of space in any of these exams. So thinking it through and be prepared. But I would argue that a complex number question should be something you're able to get the 25 marks in, depending on, I suppose, your ability. But for complex numbers, you need to know addition, subtraction, multiplication, division, how to graph it, how to find the distance of a complex number from the origin, so the modulus, and the last thing you might have to do is solve a complex quadratic equation using the quadratic formula, in other words, the minus b formula. If you know all those things, you're going to have a good time with any question, unless they ask something in an awkward fashion, but it then needs to, I suppose, be aiming for the attempts due to your knowledge. Now, in other notes, I know in 2016 paper 1, I have links in 2 different videos for doing addition, subtraction, multiplication, division, and there's practice of it in that question. They kind of, this year they haven't really asked multiplication division, but that's just the way it is. Okay, so that's question 6 done. So thanks very much for your time.